Good day everyone, we are the group 3 and we are going to discuss about the hyperbola.
A hyperbola is a geometric form in mathematics where the difference between the lengths from any point on the figure to two fixed points is a constant, from the Greek word hyperbola, which literally means overshooting or excess. This difference is taken from the distance from the farther focus and then the distance from the nearer focus. For a point Pxy on the hyperbola, and for two foci, f sub 1, f sub 2, the locus of the hyperbola is Pf sub 1 minus Pf sub 2 is equal to 2a. We refer to the two fixed spots as foci, or plural of focus. The foci of this figure are separated by two disconnected curves known as its arms or branches. The vertices of a hyperbola are the points at which its arms bend. A hyperbola is a type of conic section, a right circular conical surface and a plane that passes through both halves of the cone intersect to form a shape known as a hyperbola, according to a second definition. A third definition of a hyperbola is the collection of points for which the directrix, a ratio of the distances between a focus and a line, is constantly larger than 1. This constant is the eccentricity of the hyperbola. As mentioned, a hyperbola is an important conic section formed by the intersection of the double cone by a plane surface, but not necessarily at the center. A hyperbola is symmetric along its conjugate axis and resembles ellipse in many ways. A hyperbola is subject to concepts like foci, directrix, latus rectus, and eccentricity. Examples of hyperbola that are frequently seen include the path taken by the tip of a sundial's shadow, the scattering trajectory of subatomic particles, etc. The coordinates of a hyperbola whose center is at the origin of a Cartesian coordinate system and whose transverse axis lies on the x-axis fulfill the equation x squared over a squared minus y squared over b squared is equal to 1, where a and b are constants. The equilateral or rectangular hyperbola, in which the asymptotes connect at right angles, is a special case of the hyperbola. The equation xy is equal to c, where c is a constant, gives the rectangular hyperbola with the coordinate axis as its asymptotes. The hyperbolic sine and hyperbolic cosine functions also provide a parametric equation for the hyperbola, just as the sine and cosine functions do for the ellipse. The conjugate hyperbola is produced if the variables x and y are switched on the hyperbola equation. The asymptotes of a hyperbola and its conjugate are identical. Let us check through a few important terms relating to the different parameters of a hyperbola. First, foci of hyperbola. The hyperbola has two foci and their coordinates are f sub 1, c, o, and f sub 2, negative c, 0. Center of hyperbola. The midpoint of the line joining the two foci is called the center of the hyperbola. Major axis. The hyperbola's major axis measures 2a units in length. It runs through the center of the hyperbola and intersects both arms at their vertices. The foci are located on the hyperbola's primary axis extension. Minor axis. The length of the minor axis of the hyperbola is 2b units, a straight line that passes through the hyperbola's center and is perpendicular to the main axis. The distance from the center of the hyperbola to the vertex of the nearest branch is known as the semi-major axis of the hyperbola. Say, if point P moves along an arm of the hyperbola, and the distances of that point from the two foci are called d1 and d2, the difference between d1 and d2 remains a constant. This constant is equal to 2 times a, where a is the semi-major axis of the hyperbola. Next are asymptotes. The hyperbola starts to resemble two lines when it is distant from the foci. At the center of the hyperbola, the asymptotes cross and have slope for either a north-south opening hyperbola or an east-west opening hyperbola. Vertices. The points where the hyperbola intersects the axis are called the vertices. The vertices of the hyperbola are a0 and negative a0. Latus rectum of the hyperbola. A line that is drawn perpendicular to the hyperbola's transverse axis and passes both of its foci is known as the latus rectum. The length of the latus rectum of the hyperbola is 2b squared over a. Transverse axis. The line passing through the two foci and the center of the hyperbola is called the transverse axis of the hyperbola. Conjugate axis. The line passing through the center of the hyperbola and perpendicular to the transverse axis is called the conjugate axis of the hyperbola. A line drawn through the foci and prolonged beyond is the transverse axis of the hyperbola. Perpendicular to that axis and intersecting it at the geometric center of the hyperbola, a point midway between the two foci, lies the conjugate axis. The hyperbola is symmetrical with respect to both axes. Eccentricity of hyperbola is the ratio of the distance of the focus from the center of the hyperbola and the distance of the vertex from the center of the hyperbola. The distance of the focus is c units, and the distance of the vertex is a units. Hence, the eccentricity is E is equal to c over a.
My name is Christian Perez. Today, I'm going to explain to you what a hyperbola with center at the origin and hyperbola with center not at the origin. So we have here our equation 64x squared over 2304 minus 36y squared over 2304 is equal to 2304 over 2304. So let's process that first so that we can come up with our standard form, which is x squared over 36 minus y squared over 64 is equals to 1. So in that standard form alone, we can already find the values of our a squared, b squared, c squared, a, b, and c. So let's start with our a squared, b squared, and c squared first. So in order to find those values, we're just going to look at our standard equation. So here, our a squared here is the value of 36. So this is not the same with ellipse where the bigger value is where the a squared is. So here in hyperbola, what comes first is our a squared. So we have 36 is our a squared, and while 64, that is going to be our b squared. So in order to find the c squared, what we're going to do is to add 64 and 36, the values of a squared and b squared, and we come up with the answer of 100, which is our c squared. So next, we're going to find our a, b, and c. So all we need to do is to square root the values of a squared, b squared, and c squared in order to find the a, b, and c. So the square root of 36 is equals to 6, square root of 64 is equals to 8, and the square root of 100 is equals to 10. So let's label those parts first. So we have our a, which is equals to 6, and then that's going to be our x, 8 is going to be our y, and 10 is going to be x. So here is our latus rectum. This is the length. So we have 26 squared over a. So 2 times 64 over 6 is equal to 21.3. That's the length of the latus rectum. And that's going to find the half of the latus rectum, which is equals to 10.7, and that's going to be our y. So we have here our values. We have here the parts of our hyperbola with center, foci, vertices, and co-vertices. So we have here our center equals to 0, and foci 10 to 0, and negative 10, 0. Our vertices 6, 0, and negative 6, 0, and our co-vertices 0, 8, and 0, negative 8. So there is a graph here that shows all the values of center, foci, vertices, and co-vertices. So all of those parts are labeled here in this graph. So take a time looking at the graph and observe where the center, foci, vertices, and co-vertices are located. So for our center, we need to transpose the values of y plus 2 and x minus 7. So we have y plus 2 is equals to 0, equate that to 0. Also the same with x minus 7, equate that with 0. So we're going to transpose plus 2 or 2 into the other side. So we have our y is equals to negative 2 and negative 7, transpose it to the other side. We have x is equals to 7. So our center is 7, negative 2. And for our foci, all we need to do is to use h, comma, k plus minus c. So we already find the values of our c, which is 5.84. So all we need to do is to subtract or minus k with our c, which is 5.84. So negative 2 plus 5.84 is equals to 3.83. So we have here our first focus. So 7, 3.83. And for the other one, we need to subtract negative 2 by 5.84 so that we can find the other focus. So we have 7.83 and our second focus is 7 and negative 7.83. And for our vertices, we're also going to use same formula, but we're going to change c with a. So h, comma, k plus minus a. So let's substitute our values of h, 7, and k is equals to negative 2, and a is to 5. So we're going to add negative 2 to 5. So we have 3. So our first vertex is 7, 3. And our second vertex is 7 and negative 7. We just subtract negative 2 by negative 5. We also have here our asymptote, which is equals to y minus the quantity of negative 2 is equals to plus minus 5 over 3 times the quantity of x minus 7. So we have here our graph. You can find here in our graphs our center, foci, and our vertices. So today, we're going to find the equation in standard form of the hyperbola having the described features. Foci is equal to negative 3, 0, and 3, 0. And for any point in the hyperbola, its distances from the foci differ by 4. So we have here our center, which is equals to 0, 0. And the value of our c is equals to 3, which is already found in our foci. And the next thing that we're going to do is to find the values of our a squared and b squared so that we can already have our standard form. So we already have our value for our a. And the next thing that we're going to do is to square our value for a in order to find our a squared. So we have 2 squared is equals to 4, and that's the value for our a squared. Next thing that we're going to do is to find the value of b squared. So in order to find the b squared, let's find first our b. So in order to find our b, we need to use the formula on how to find the c. So you have here c is equals to square root of a squared plus b squared. So let's substitute the values. We already have the values of c and a. So we have c is equals to 3 and a is equals to 2. So we have 3 is equals to square root of 2 squared plus b squared. So let's square the entire equation so that we can get rid of this square root. So we have 9 is equals to 4 plus b squared. So let's transpose 4 onto the other side. So we have 9 minus 4 is equals to b squared. And then subtract 9 by 4. So we have b squared is equals to 5. And then we're going to square root the b squared. So we have b is equals to square root of 5. And then we're going to square our square root of 5 so that we can find the value for our b squared, and our b squared is equals to 5. So we already have here our standard form is x squared over 4 minus y squared over 5 is equals to 1. So we have here another example. So we have the examples of vertices, focus, and center. So this equation is not found in the origin, not found in the center, and we have the values of our vertices, focus, and center this time. So for our vertices, we have 5, 1, and 5, negative 5. For our focus, 5, negative 8, and for our center, 5 and negative 2. So we already have our value for A and C. Next thing we're going to do is to find the value of B. All we need to do is to use the formula on how to find the C, which is C is equals to square root of A squared plus B squared. Next thing we're going to do is to substitute the values. So we have C is equals to 6, A is equals to 3, and then we're going to square the entire equations to get rid of the square root. And so we have 36 is equals to 9 plus b squared. Transpose 9 into the other side. So we have 36 minus 9 is equals to p squared. And we have 25 is equals to p squared. And then we're going to square root our 25. So we have b is equals to 5. So we have here our standard form. Quantity of y minus k squared over a squared minus quantity of x minus h squared over b squared is equals to 1. Let's substitute the values. We have k is equals to negative 2, h is 5. And for our a, which is 3, and for our b is 5. So we need to square 3. So we have 9, and let's also square 5, which is 25. So we have here our standard form, quantity of y plus 2 squared over 9 minus the quantity of x minus 5 squared over 25 equals to 1.
We have here the standard equation for hyperbola with center at hk, in which there are two equations for the transverse axis at either horizontal or vertical. The standard form of the equation of a hyperbola with center hk, the transverse axis parallel to the x-axis, or when the transverse axis is horizontal, the standard equation is the quantity of x minus h squared over a squared minus the quantity of y minus k squared over b squared is equal to 1, wherein the length of the transverse axis is 2a, the coordinates of the vertices are h plus minus a, k, the length of the conjugate axis is 2b, the coordinates of the co-vertices are h, k plus minus b, the distance between the foci is 2c, where c squared is equal to a squared plus b squared, and the coordinates of the foci are h plus minus c, k. Also, that is the standard form of the equation for the hyperbola with center at hk, the transverse axis parallel to y-axis, wherein it is vertical. The standard equation will be the quantity of y minus k squared over a squared minus the quantity of x minus h squared over b squared is equal to 1, wherein the length of the transverse axis is 2a. The coordinates of the vertices are h, k plus minus a. The length of the conjugate axis is 2b. The coordinates of the co-vertices are h plus minus b, k. The distance between the foci is 2c, where c squared is equal to a squared plus b squared. And the coordinates of the foci are h, k plus minus c. You can see the difference in the equations. Where what quantity started. Here we have the quantity of x minus h squared that is started for the horizontal transverse axis, and then for the vertical transverse axis, the quantity of y minus k squared started the equation. And here we have provided you two examples for each standard equation. So now for example number 1, find the coordinates of the center versus foci of the equation. The quantity of y plus 2 squared over 16 minus the quantity of x minus 3 squared over 9 is equal to 1. So that standard equation is for the standard equation of the quantity of y minus k squared over a squared minus the quantity of x minus h squared over b squared is equal to 1. Wherein we can see that the transverse axis is vertical since the quantity of y minus k squared started the equation. And 16 is greater than 9, which means that the transverse axis is longer than the conjugate axis. So for our center, we have 3 and negative 2. Our value for h is 3. Our value for k is negative 2. And now let's solve for the a, b, and c. For a, we have a squared is equal to 16. And to find the value of a, we will square root 16, so we can cancel the square in the a. So square root of 16 is equal to 4. So our value for a is 4. For b, we have b squared is equal to 9, and the square root of 9 is 3, and that is our value for b. For c, we will use the formula, the square root of a squared plus b squared. So a squared is 4 squared, and b squared is 3 squared. So 4 squared is 16, 3 squared is 9. So the square root of 16 plus 9 is square root of 25. The square root of 25 is 5. So that is our value for c. We will then now find the vertex, and we will use h, k, plus minus a. Our value for h is 3. Our value for k is negative 2, and our value for a is 4. So copy h. Negative 2 plus 4, we have 2, and negative 2 minus 4, we have negative 6. So vertex 1 is 3, 2. Vertex 2 is 3, negative 6. And for co-vertex, we will use h plus minus bk, which our value for h is 3. For b, we have also 3, and for k, we have negative 2. So 3 plus 3 is 6, 3 minus 3 is 0, and copy negative 2. So our value for co-vertex 1 is 6, negative 2, and our value for co-vertex 2 is 0, negative 2. Now we will now find foci. So we will use h, k, plus minus c. For h, we have 3, for k, we have negative 2, and for c, we have 5. So copy the h, which is 3, and negative 2 plus 5 is 3, and negative 2 minus 5 is negative 7. So for foci 1, we have 3, 3, and for foci 2, we have 3, negative 7. Now we will now find lactus rectum, which we have the formula b squared over a. For b squared, we have 3, 3 squared, and a, we have 4. So 3 squared is equal to 9. So 9 over 4 is equal to 2.25. Now we will now find the endpoints of the lactus rectum. We will use h plus minus lr, k plus c, and we will also use h plus minus lr, k minus c. For h, we have 3. For the lr, we have 2.25. For k, we have negative 2, and for c, we have 5. So 3 plus 2.25, we have 5.25. 3 minus 2.25, we have 0.75. Negative 2 plus 5, we have 3. So our value for LR1, we have 5.25, 3. For LR2, we have 0.753. And for the other one, we have h plus minus LR, k minus c. H is 3, LR is 2.25, k is negative 2, and c is 5. So h, 3 plus 2.25 is 5.25, and 3 minus 2.25 is 0.75, and negative 2 minus 5 is negative 7. So for LR3, we have 5.25, negative 7, and LR4, we have 0.75, negative 7. So those are the endpoints for our lactus rectum. So what we all solve are the coordinates for the center, vertex, co-vertex, foci, lactus rectum. It is under the equation given. For the next example, find the coordinates of the center, vertices, co-vertices, And foci, the equation of the quantity of x plus 2 squared over 4 minus the quantity of y plus 5 squared over 12 is equal to 1. That standard equation is from the standard equation of the quantity of x minus h squared over a squared minus the quantity of y minus k squared over b squared is equal to 1. And as you can see, this equation started with the quantity of x plus 2 squared, which means that its first axis is horizontal. And 4 is less than 12, which means the conjugate axis is longer than its first axis. So first, we will find the value for our center. For our center, we have -2 and -5. H is equal to -2 and K is equal to -5. Next, we will now find our value for A, B, and C. For A, we have A squared is equal to 4. And since we need to cancel squared to get the value of A, we have the square root of 4, which is 2, so A is equal to 2. For B, we have B squared is equal to 12. To cancel squared, we will find the square root of 12. So B is equal to square root of 12 since we cannot simplify that element. For C, we will use the formula. The square root of A squared is B squared. For A squared, we have 4 squared. And for B squared, we have square root of 12 squared. So the square root of 4 squared plus square root of 12 squared is the square root of 4 plus 12. So square root of 16 is 4. So for our C, we have 4. Next, we will find vertex. For vertex, we have H plus minus AK, which our H is -2, our A is 2, our K is -5. So -2 plus 2 is 0, -2 minus 2 is -4. Copy -5 for K. So our vertex 1 is 0, -5, and vertex 2 is -4, -5. Next, we will find our co-vertex. So we will use H, K plus minus B. For H, we have -2. For K, we have -5. For B, we have square root of 12. So copy H, -2, and -5 plus square root of 12, and -5 minus square root of 12. So our co-vertex 1 is -2, -5 plus square root of 12, and our co-vertex 2 is -2, -5 minus square root of 12. Next is for our foci. We have H plus minus C, K. For H, we have -2. For C, we have 4. And for K, we have -5. -2 plus 4 is 2. -2 minus 4 is -6. And just copy K, -5. So our foci 1 is 2, -5. And our foci 2 is -6, -5. And lastly, we will find our value for lactus rectum. We will use the formula B squared over A. B squared is square root of 12 squared, and the A we have 2, so square root of 12 squared is 12 over 2, so 12 over 2 is equal to 6, so that is our lactus rectum. And also, we will also find the endpoints for our lactus rectum. We will use H minus C, K plus minus LR, which is our lactus rectum. And we will also use H plus C, K plus minus LR. So H, we have -2, C, we have -4, K, we have -5, and LR, we have 6. So -2 minus 4, -6, -5 plus 6 is 1, -5 minus 6 is -11. Our endpoint 1 is -6, 1. Our endpoint 2, we have -6, -11. And for the endpoint 3 and 4, we have H plus C, K plus minus LR. So H is -2, C is 4, K is -5, and LR is 6. So -2 plus 4, we have 2. -5 plus 6 is 1. -5 minus 6 is -11. So our endpoint 3 is 2, 1. Our endpoint 4 is 2, -11. So those are the coordinates of the center, vertices, co-vertices, foci of the given equation. A hyperbola with a horizontal transverse axis and center at hk has one asymptote with an equation y is equal to k plus b over a times the quantity of x minus h, and the other with the equation as y is equal to k minus b over a times the quantity of x minus h. Also, that a hyperbola with a vertical transverse axis and center at hk has one asymptote with the equation y is equal to k plus a over b times the quantity of x minus h, and the other with the equation y is equal to k minus a over b times the quantity of x minus h. How to? Given the vertices and foci of hyperbola centered at hk, write its equation in standard form. If you are given that kind of problem, first determine whether the transverse axis is parallel to the x or y axis, if it is horizontal or vertical. If the y coordinates of the given vertices and foci are the same, then the transverse axis is parallel to the x-axis, which means it is horizontal. You can then use the standard form of the quantity of x minus h squared over a squared minus the quantity of y minus k squared over b squared is equal to 1. If the x coordinates of the given vertices and foci are also the same, then the transverse axis is parallel to the y-axis, which means it is vertical. You can use the standard form y, the quantity of y minus k squared over a squared minus the quantity of x minus h squared over b squared is equal to 1. First, identify the center of the hyperbola hk using the midpoint formula and the given coordinates for the vertices. Now find a squared by solving for the length of the transverse axis 2a, which is the distance between the given vertices. Find c squared using h and k found in step 2, along with the given coordinates for the foci. Solve b using the equation b squared is equal to c squared minus k squared. And lastly, substitute the values for h, k, a squared, and b squared into the standard form of the equation determined in step 1. And we have here an example for that. So what is the standard form equation of the hyperbola that has vertices at 0, -2, and 6, -2, and foci at -2, -2, and 8, -2? For our solution, the y coordinates of the vertices and foci are the same, so the transverse axis is parallel to the x-axis, which means that our equation is horizontal. Thus, the equation of the hyperbola we will have is the form of the quantity of x minus h squared over a squared minus the quantity of y minus k squared over b squared is equal to 1. First, we identify our center, which is hk. The center is halfway between the vertices 0, -2, and 6, -2. Applying the midpoint formula, we have hk is equal to the quantity of 0 plus 6 over 2, -2 plus -2 over 2. Our 0 plus 6 over 2 is 3, and -2 plus -2 over 2 is -2. So that is our center. Our h as 3 and k as -2. Our center is 3, -2. Next we will find is our a squared. The length of the transverse axis 2a is bounded by the vertices. So we can find a squared by finding the distance between the x coordinates of the vertices. 2a is equal to the absolute value of 0 minus 6. The absolute value of 0 minus 6 is 6, and 6 divided by 2, so we can cancel 2. So what is left there is a. So 6 divided by 2 is 3. A is equal to 3. A squared is equal to 9, since 3 squared is 9. Now, we need to find our c squared. The coordinates of the foci are h plus minus ck. So h minus ck is equal to negative 2, and h plus ck is equal to 8, negative 2. We can use the x-coordinate from either of these points to solve for our c. Using the point 8, negative 2, and substituting h as 3. h plus c is equal to 8. 3 plus c is equal to 8 since we will substitute h as 3. Transpose 3, so 8 minus 3 is 5. So our c is equal to 5, and c squared is equal to 25 since 5 squared is 25. Next, we will solve is our b squared. We will use the equation b squared is equal to c squared minus a squared. So our c is 5, our a is 3. 5 squared is 25. 3 squared is 9, so 25 minus 9 is 16, and that is our value for b squared. Finally, substitute the values found for h, k, a squared, and b squared into the standard form of the equation. So for h, we have negative 3, for k, we have, for h we have 3, and for k we have negative 2, for a squared we have 9, and for b squared we have 16. So our equation will now be the quantity of x minus 3 squared over 9 minus the quantity of y plus 2 squared over 16 is equal to 1. So that is our final answer. Another how-to is when you are given a general form for a hyperbola centered at hk and you need to sketch the graph. So first, convert the general form to the standard form. Determine which of the standard forms applies to the given equation. Use the standard form identified in step 1 to determine the position of a transverse axis, coordinates for the center, vertices, co-vertices, and foci, and equations for the asymptotes. If the equation is in the form of the quantity of x minus h squared over a squared minus the quantity of y minus k squared over b squared is equal to 1, then our transverse axis is parallel to the x-axis, which means it is horizontal. The center is hk. The coordinates of the vertices are h plus minus ak. The coordinates for the co-vertices are h, k plus minus b. The coordinates for the foci are h plus minus b, k. And the equations of the asymptotes are y is equal to plus minus b over a times the quantity of x minus h plus k. If the equation is in the form of the quantity of y minus k squared over a squared minus the quantity of x minus h squared over b squared is equal to 1, then our transverse axis is parallel to the y-axis, which means it is vertical. The center is at hk. The coordinates of the vertices are h, k plus minus a. The coordinates of the co-vertices are h plus minus bk. The coordinates of the foci are h, k plus minus c. And the equations of the asymptotes are y is equal to plus minus ab times the quantity of x minus h plus k. Next, we will solve for the coordinates of the foci using the equation c is equal to plus minus the square root of a squared plus b squared. And lastly, plot the center, vertices, co-vertices, foci, and asymptotes in the coordinate plane and draw a smooth curve to form the hyperbola. We have here an example for that. Graphing a hyperbola centered at hk given an equation in general form. So we need to graph the hyperbola given by the equation 9x squared minus 4y squared minus 36x minus 40y minus 38 equal to 0. We should identify and label the center, vertices, co-vertices, foci, and asymptotes. So we will start by expressing the equation in standard form. So we will convert it to standard form. So from general form to standard form. We will group the terms that contain the same variable and move the constant to the opposite side of the equation. So we have the quantity of 9x squared minus 36x minus the quantity of 4y squared plus 40y is equal to 38. Factor the leading coefficient of each expression. So our equation would go like 9 times the quantity of x squared minus 4x minus 4 times the quantity of y squared plus 10y equal to 38. Complete the square twice. Remember to balance the equation by adding the same constants to each side. So 9 times the quantity of x squared minus 4x plus 4 minus 4 times the quantity of y squared plus 10y plus 25 equal to 38 plus 9 times 4 minus 4 times 25. So we will write it as perfect squares. So it will go like 9 times the quantity of x minus 2 squared minus 4 times the quantity of y plus 5 squared is equal to 324. 324 is from 388 plus 9 times 4 minus 4 times 25. Divide both sides with constant term to place the equation in standard form. So divide 9 times the quantity of x minus 2 squared minus 4 times the quantity of y plus 5 squared to 324. 324 divided by 9 is 36. 324 divided by 4 is 81. So we have now our standard equation. Our standard equation is the quantity of x minus 2 squared over 36 minus the quantity of y plus 5 squared over 81 is equal to 1. The standard form that applies to the given equation is the quantity of x minus h squared over a squared minus the quantity of y minus k squared over b squared, which means that our transverse axis is horizontal, where a squared is equal to 36 and b squared is equal to 81, or a is equal to 16 since the square root of 36 is 6. Our a is equal to 6 and b is equal to 9 as the square root of 81 is 9. Thus, the transverse axis is parallel to the x-axis, or again, it is horizontal. It follows that the center of the ellipse is hk is equal to 2, negative 5. The coordinates of the vertices, or h plus minus ak, is equal to 2 plus minus c, negative 5. Or negative 4, negative 5, and 8, negative 5. The coordinates of the co-vertices, or h, k, plus minus b, which is equal to 2, negative 5, plus minus 9, or 2, negative 14, and 2, 4. The coordinates of the foci are h plus minus c, k, where c is equal to 2 plus minus the square root of a squared plus b squared. Solving for c, we have 36 as our a squared, 81 as our b squared, so 36 plus 81 is 117, and the square root of 117 is 3 square root of 13. That is our value for c. Therefore, the coordinates of the foci are 2 minus 3 square root of 3 minus 5, and 2 plus 3 square root of 13, negative 5. The equation of the asymptotes are y is equal to plus minus b over a times the quantity of x minus h plus k, which is equal to plus minus 3 over 2 times the quantity of x minus 2 minus 5. Since our b is 3, our a is 2, our h is 2. Next, we plot and label the center, vertices, co-vertices, foci, and asymptotes, which we solved earlier, and draw a smooth curves to form the hyperbola. So here you can see the hyperbola that we formed. You can see it in the screen. So that is how we graph an hyperbola given a general form in which we will convert it to standard form. And that sums up our report on hyperbola. Don't hesitate to ask any questions. Thank you for listening.